So the reaction started about 6 o'clock. It's now 6:25, so it's been going about 25 minutes. Got about 5 minutes to go. And you can see that the temperature is about 132 or so, kind of stabilized. To get there, I needed my setting between 150 and 200, almost exactly halfway between there, to maintain that. You can see it's bubbling pretty vigorously. I don't know if the camera shows it up, but I can see the reflux line very clearly right at the bottom of the condenser, where it's condensing, and you see it kind of moving back and forth as liquid condenses on the inside of the condenser. So that's a good temperature, 132. It's been pretty constant. The other thing I've been checking while you've not been watching, because I haven't been filming, is I've been checking that to make sure that the liquid doesn't suck back, so it stays in contact. And I don't know if you can see it, but you can see that the liquid's moving up and down a little bit as some gas builds up. So I'm going to put a spatula tip of the, it says sodium carbonate in the lab manual, but potassium carbonate is what I found, anhydrous potassium carbonate, so that's what I'm going to use. And I just need, a little bit of a tip of a spatula. It doesn't take a lot. Yeah, maybe that much. Just kind of a little bit in the bottom, just to react with any excess acid. I'll add just a little bit more. And that looks like a good amount. It's about halfway up to the 0.1 milliliter mark. Like I said, the anhydrous potassium carbonate is going to do two things. One, it's going to absorb any water that's formed during the reaction or that came with the benzoyl peroxide. And two, it's going to react with any of the sulfuric or hydrochloric acid that's formed in the process. This isn't really dirty, so I'm just going to give it a little wipe. I can put that away. And we can put the potassium carbonate back in the cabinet it belongs in over here. And I'm going to put that cap on there so moisture from the air doesn't get into it. So I got my Hickman still ready, and I'm refluxing away, and it's been pretty close to half an hour. I'm going to need a pipette to remove the liquid, so I'll get that ready too. So that's what I'm going to be putting into the side arm of the Hickman still. And like I said, with these pipettes, what I like to do so that they stay upright and I don't contaminate them is have them in a little Erlenmeyer flask, so I can store it in between in there. And this can go back to the balances because that's the last pipette I'm going to need today. It usually lives on the tray right next to the balances. So now I want to let the contents cool, but I really want the hot block to stay at temperature because I'm going to be using it again. I'm going to take the thermometer out just so I don't break it for now. And then I'm going to cool it by just raising the entire assembly up and rotating it out of the way, trying not to, kink those hoses, so I can kind of set it down away from the hot plate. A little bit, so that'll allow that to cool. I really just need it to cool so I can handle it, so I can put the Hickman still in place. Because this is now cooling, it's going to have a tendency to suck this liquid back, so I'm going to keep an eye on that and make sure that doesn't happen. And once I do the distillation, I won't actually need that assembly because no more HCl is going to be being generated. So as soon as that cools so it stops bubbling, I can actually disconnect my tubing. And it looks safe. I'm going to pull that off of there. You can see there's a little bit of liquid in there. That's probably some water. I disconnect that. This tubing has HCl in it. So I'm actually going to want to run a bunch of water through there so it doesn't get crusty. The way these hose clamps come off is you just move them to the side, and you can see if you look at it that this one has like an inner piece that only goes halfway. So it clicks on, but then if I move it just a little bit, like halfway to the side, then I can get it to come apart. So I'm done with the tubing clamp, and put that back. Pull that off of there, and I'm going to sit that over here so I can run some water through it once we're done here. And then I don't need this anymore. So I'm waiting for things to cool. I can also disconnect this. That'll need to be rinsed. These guys can go back in their drawer. You notice I took them apart. Always take them apart. If you look in the bottom, you notice it's kind of gone a little bit black there. That's from the heating with the benzoyl peroxide. That's normal. We'd expect that to happen. This guy back too. That's from the action of the acid and the sulfuric acid that the sulfuryl chloride is being converted into. Yeah, it's still a little too hot. Wait a little longer. You notice I didn't have to turn the water off either because it's only going through the outer jacket, so it's not hurting anything to just leave it going. Sodium hydroxide is basically Drano, so I'm just going to let that go down the sink with lots of water. And I can sit the beaker in there and let it gradually rinse. And after I take the O-ring and the nut on there, I can sit that in there as well. These guys can go back in their jars. A little warm. Probably could handle it now, but I just will not burn myself. Yeah, that'll do. So I'm going to disconnect that, pull that vial off, and then I'm just going to insert my Hickman still in between the two. And I want that to be off the right so I can get at it easily since I'm right-handed. And then the vial gets put back on the bottom. Make sure that's tight, and that's tight, and that's on tight. Now I can rotate this and stick it back in there. It can be heating back up. So I'm still stirring at about 600 on the stir. I got nice vigorous stirring, so it works. And I'm still up around 130. I'm going to crank that back up a little. I'll have to heat it hotter to get the reflux line to go all the way up to the condenser. So I'm going to put that back at 200. And put my thermometer in here so I'll know what the temperature is. And I've got my pipette ready and my vial ready so that when things start to condense in there, I'll be able to pull it out. And I'm going to put that back there so that it doesn't any problems. I don't want this to come into contact with the hot plate. So I'm going to rotate the condenser a little bit so the condenser hose is pointing back away from everything else. That'll give me a easier access to the side arm as well. And it will allow me to get that hose, hopefully, a little bit more out of the way. I can rotate this as well. There we go. So I have an unobstructed path to getting at my sidearm. And it's not quite straight. I'll straighten that up a little bit. So I'm boiling again. Temperature's back up around 135 to 140. And I will start to see liquid collecting in there at some point. And sometimes to make that stay hot down there, it's productive to take a little bit of glass wool and a piece of foil, and I can wrap this glass wool around so that the whole vial stays hot. And hold it in place with some foil. The goal is to keep everything below the well where we're trying to collect product hot, but not obviously in contact with the well, because the well has to stay cold. So I'm just going to wrap that a little bit. That should speed up the condensation. It's not really science, it's more art. And you can see that that's already filled. So we're up at 150. That's hot enough. I'm going to back this off again to maybe like 180 setting there. That's the temperature I want. And I want to work fairly fast because I don't want that material to disappear. So I quickly take this off and just pull out the contents of that well, transfer it into my vial, and replace the cap. I'm going to do that fairly quickly so I don't lose material. And then put this cap back on again so I don't get material evaporating. And I'm waiting for it to fill again. And it's actually coming over pretty quickly. So it's already filled again. Oops, that was not a good thing. Fortunately, it didn't get wet. That's collecting. Another pipette full. Put my lid back on. Usually things go butter side down, but that time that worked. And I'm just trying to distill all but about half a milliliter of it. It'll stop filling quite so quickly once I get close to the end. Another pipette full. And we're a little bit below 150. Tweak that back up again, closer to 200. It's really never reaching the condenser, it's just kind of cooling, right? Because this part's cool relative to the stuff down there. You'll see that my tin foil is not quite touching the well. It looks like it's pretty much full again. I want to make sure I get all of it because I don't want to change the ratio of the chlorides by not completely distilling it or by losing material. Looks like there's still some more forming. So the distillation is not done. It's definitely slowed down. To get that last residue, I'm going to end up having to tilt this a little bit. So once I cool everything down, I'll get that last little bit. Yeah, looks like it's about done. I'm going to take one more pipette load. I think I can get a little bit more out of there. So you see I've got just shy of 3 milliliters, which is probably most of it. That's not a very accurate reading. And it really doesn't seem to be condensing very readily, so I'm going to take the foil off the glass wool carefully because it's hot. I can put that back. And then I'm just going to take a peek in there and see if it looks like it's pretty much done distilling. Take the thermometer out here so I don't break it. And I'm just going to lift it up. It says you're supposed to distill it till there's a little less than half a milliliter or so. Maybe it can go a little longer. Might be a little bit more left. Get up to 200 just to make sure we get everything over. There is a little bit more liquid forming.